Back to my speed max and math electrical for you. We are going to sketch the Bode plot in which we need to construct two plots. One is the magnitude plot, the second is the phase plot. So gain in dB versus frequency will be our magnitude plot. Phase difference versus frequency will be the phase plot. Sketch the Bode plot for the gain K, whose gain crossover frequency to be 5 radian per second. The given transfer function is g of s is equal to k into s square divided by 1 plus 0.2 into s and 1 plus 0.02 into s. Substitute k is equal to 1 and s is equal to j omega in this transfer function. So we'll get 1 into j omega the whole square divided by 1 plus 0.2 j omega 1 plus 0.02 into j omega. Rearrange the equation, we'll get in the transfer function like this. So here we have three terms. The first term is here j omega the whole square and two denominator terms are there. So we need to choose the corner frequency for the magnitude plot. So magnitude plot and the phase plot are the two plots we need to construct. First we'll see the magnitude plot. So omega c1 and omega c2. The corner frequencies are omega c1 is 1 by 0.2, so 5 radian per second. 1 by 0.02, it is 50 radian per second. The term which involves the real and imaginary only from the denominator. Table 1. So in this table 1 we are going to construct the magnitude plot. So term, corner frequency, slope, change in slope. To the given transfer function we need to construct this various value of g of j omega in their order of the highest corner frequency value and change in slope for the every corner frequency. So when see this transfer function we have three terms here. So we'll see one by one term how to write the table for this three terms here. So first term is j omega. So first term is j omega the whole square. Corner frequency is not there. Slope is 40. For every s value you have to replace it by 20 decibel per decade. So change in slope is 40 or we can write as it is hyphen. The second term is 1 plus j 0.2 omega. So it is in the denominator term. So omega c1 is 1 by 0.2. It is 5 radian per second. Slope decibel is minus 20 since the s term is in the denominator. Change in slope will be 40 minus 20, so it is 20. And the third term is 1 plus j 0.02 omega, that term is also in the denominator. So the corner frequency is 1 by 0.02 omega, omega c2 is equal to 1 by 0.2, so it is 50 radian per second. Change in slope is minus 20, so it is 20 minus 20, so it is equal to 0 there. So how many terms we have seen? We listed out here. First term is j omega the whole square, second term is 1 plus j 0.2 omega and third term is 1 plus j 0.02 omega. All the last two terms are in the denominator and the first term is in the numerator. The table is listed above there. We need to choose the lowest corner frequency and as well as the higher corner frequency. Choosing the lower corner frequency value will be taken as omega L and choosing the higher corner frequency value will be taken as omega H. So based on that, we'll choose omega L as 0.5 and omega H as 100. So gain in dB is given by A is equal to magnitude G of j omega in dB. So table 1, which is nothing but the magnitude plot here. So omega is equal to omega L, we are taking it as 0.5 radian per second. So we'll see how to calculate the gain in dB for the chosen of the various corner frequency values. Omega equal to omega L, A is equal to 20 log of G of j omega, so 20 log of 0.5 the whole square, so it is minus 12 dB. Second term, omega equal to omega c1 is equal to 5. So omega equal to omega c1, A is equal to 20 log of j omega the whole square, so 20 log of pi square, so it is 28 decibel. And third one, we need to use the formula. Slope from omega c1 to omega c2 into log of omega c2 by omega c1 plus the previous gain magnitude value. So it is 20 into log of 50 by 5 plus previous gain is 28. So it is 48. And the last one is omega equal to omega h is 100. So slope from omega c2 to omega h into log of omega h by omega c2 at the previous omega equal to omega c2. So 0 into log of 100 by 50 plus 48, so it is equal to 48. So this is the construction of your magnitude plot table. Next we will see how to construct your phase plot. So before constructing the phase plot, we need to write the phase equation. So write the transfer function as it is after substituting s is equal to j omega. So the first term is j omega the whole square, so it is written as 180 degree. The second term is 1 plus j 0.2 omega, so it is both real and imaginary term here. So which is nothing but tan inverse of imaginary part divided by real part. So it is 0.2 omega, and the third term is 1 plus j 0.2 into omega. So it is tan inverse of 0.02 into omega. Now we'll see the table how to construct your phase plot. So first we will take the various values of omega. For understanding purpose, one calculation is shown here directly, and the other calculation you can check out from the description in the link which is given how to calculate this by using a calculator. So phase angle is g of j omega in degree, and omega is in radian per second. First we will take it as 0.5 and we'll get it as 174. Write the phase angle equation as it is. Substitute the value of 0.5 everywhere wherever we have omega term in the g of j omega, that is phase angle. So you'll get 180 degree minus tan inverse of 0.2 into 0.5 minus tan inverse of 0.02 into 0.5, you'll get 74. For 1 we'll get 168, for 5 we'll get 130, 10 for 106, 50 for 50, 100 for 30. All these values are written in approximately in order to plot the graph very easier. So the calculation work will be shown here how we have done this calculation. Now we'll see how to sketch the Bode plot using the Semilog sheet from the data what you obtained for the magnitude plot and as well as the phase plot. Omega in radian per second, we have taken the data as 0.5, 5, 10 and 100. The corresponding calculation we got it as minus 12, 28, 48 and 48. The various values of the omegas are given and the phase corresponding is also given. Choosing the scale in the Semilog sheet is very important. So we'll take the scale values as 0.1, 0.5, 1. When you see the difference is 1 is from here to here. So next will be 5, 10, 50, 100 omega in radian per second. The corresponding gain what you have obtained is from minus 12 to 48. So we'll take it as starting from 50, 40, 30, 20, 10, 0, minus 10, minus 20 and minus 30. And the corresponding frequency value what you got it from minimum is 30 and maximum is 174. So we'll go from 30 to 180 on the same y-axis in the same Semilog sheet. So gain in dB is given in the y-axis. The same gain in phase in degree is also given 30, 60, 90, 120, 150 and 180.